Hey everyone, I am Adi, the ETO working on offshore vessels, and today I am taking you straight inside our DP2 ship's main switchboard, the MSB, the real heart of our entire power system. Let's jump in and see how this switchboard controls the propulsion, thrusters, and everything that keeps the vessel moving. So, the main switchboard or the MSB is where all electrical power is generated, controlled, protected, and distributed. So, from this switchboard, we supply power to the propulsion, thrusters, crane, pumps, accommodation, navigation, basically everything that keeps the vessel running. So, for a DP2 vessel, we need redundancy. That means even if one side of the power system fails, a generator or breaker or even a full bus bar, still the vessel should maintain its position for a short time. To come out of, suppose if the vessel is working near a platform, for a short period of time, even if the bus bar fails, the vessel should maintain its position and come out of the danger. So basically our MSB is split into two independent sections, one port side bus bar and the other is starboard side bus bar. So this is our port side bus bar. It is supplied by generator number 1 and 2. So as you can see, the generator number 1 is G1. Right now it is running. It's 440 volt and it's sharing around 700 kilowatt. And generator number 2 is off. So basically generator number 1 is giving power to the all loads in the port side bus bar. And this is our best tiebreaker and it is open. And this is the starboard side, and in starboard side generator number 3 is running and generator number 4 is off. So basically port side bus bar is powered by generator number 1 and it is giving power to the main propulsion number 1. You can see it's a main propulsion number 1. It's an electrical propulsion drive, so it is getting power from the port side bus bar. And similarly on the starboard side we have main propulsion 2 which is getting power from the starboard side bus bar. So and the best tiebreaker is open. So basically during DP operations the best tiebreaker should remain open to maintain the redundancy. And we also have a compass thruster which can be feed by either port side or starboard side, depends upon your requirement. So there will be a changeover switch to change the bus bar of starboard side. For the compass thruster you can take power from either port or the starboard side. So basically in DP mode the best tie is normally open, meaning both bus bars run independently. And these are the 440 volt loads which are connected to the port side bus bar. You can see the distribution panel P1, P3 and P5, and P2 and P4 will be on the starboard side bus bar. So these are the 440 volt loads which are connected to the port side bus bar. And similarly we have on the starboard side also the starboard 440 volt loads. And all the auxiliary pumps for the thrusters, propulsions, everything will be on the 440 bus bar side. And now on the generator number 1 is running, and similarly we have the 230 volt bus bars. As you can see, this is the 230 volt bus bar. We have a 2 transformers which step down the 440 volt to the 230. And since it's a DP2 vessel, for the 230 volt bus bar also we have tiebreaker which should be opened, like similar to the 440 volt side. So 230 volt bus bar port side will be powered from the main port side bus bar, and starboard 230 volt will be powered by the main starboard bus bar. So all the 230 volt load, all the breakers will be connected to this bus bar. And apart from that, there are a lot of protection and safety systems for the main switchboard, like overload protection, short circuit protection, earth fault monitoring, reverse power protection, under and over voltage and frequency, bus bar differential protection, breaker failure protection. And these systems ensure that the switchboard stays healthy, especially during heavy loads. I will open the generator 1, generator number 2 panel, and you can see the main breaker of generator number 2. Right now generator number 2 is off, and when it is on, we will close this breaker and it will give power to the port side bus bar. And these are the protection settings, and we have a lot of relays, PLCs, breakers for the protection of the main switchboard. So basically there will be a power management system. It works together with the DP system. So during the DP controller requests power based on the thruster demands. And on our vessel we have DAVE Delomatic 3 power system. You can see the Delomatic panel on each of the generator control panel. It basically do the automatic generator start and stop, load sharing, load dependent start, power balancing, blackout recovery, isolating the faulty bus sections. So even if one power group trips, the other group continues powering the thrusters. And why this layout is important, like for a DP2 vessel? So this layout ensures we always have at least one working propulsion and one bow thruster from each independent power group. So even with a failure, we maintain enough thrust to hold the position for a short time, which is exactly what DP2 requires. So that's a full breakdown of our DP2 vessel's main switchboard and how the power is distributed on board. This setup gives us a strong redundancy and stable power during all operations. So basically, if you have enjoyed this video, hit like, subscribe, and drop a comment telling me which system you want me to explain next. There are thrusters, PMS logic, generators, or crane power distribution. You can drop a comment. Thanks for watching. Stay safe.